Hey everyone, so at this point we have learned about the Pythagorean theorem. There's also a converse to the Pythagorean theorem, which just says that if a squared plus b squared is equal to c squared, given three sides of a triangle, then that's a right triangle. Um, I said it in shortened terms, obviously. There's also two other theorems that have to do with acute and obtuse triangles. So for the acute triangle, the length of the longest side squared is less than the sum of the other two sides squared. So c squared, the longest side, is smaller than the other two sides squared. Or in other words, a squared plus b squared is greater than c squared. And then for an obtuse triangle, you can probably guess at this point, a squared plus b squared is going to be smaller than c squared. So the third side, the longest side squared, is going to be bigger than the other two. So here are three different cases. And we can actually use these ideas now, use these different inequalities to figure out, given any three side lengths, if it's going to be an acute triangle, a right triangle, or an obtuse triangle. And we do need to remember, so like in our first couple examples, it says here, decide whether the numbers could represent the sides of a triangle. So we still need that triangle inequality to hold. If you forget what that is, let's look at one that doesn't work. Of course, all of these ones in the beginning work. Well, we'll get there in a second then. So let's try this out. So A, B, and C, just the main thing is that you have to remember that C is always the longest side. So here I would have 3 squared plus 5 squared, and I want to compare it to 7 squared. I always just leave this blank, or you could kind of do like a circle to fill in the blank at the end. So we get 9 plus 25, and we want to compare that to 49. 9 plus 25 is 34, which is less than 49. And so I can look up here. That means that this is an obtuse triangle. The next one, so 16 squared plus 30 squared, and we want to compare that with 34 squared. 16 squared is 256. 30 squared is 900. And then 34 squared is 1,156. So let's see. Oh, yep, that one looks like it will be a right triangle because it ends up working out. So that would be, remember, this is what a Pythagorean triple. This would be an example of a Pythagorean triple because all of the numbers are whole numbers. There's no decimals or square roots. So this is a right triangle. And let's see, number 3. 14 squared plus 48 squared in comparison to 50 squared. So 14 squared plus 48 squared gives me 2,500, and 50 squared also gives me 2,500. So again, this is a right triangle. So that's another Pythagorean triple. All right, so let's try 3 more, and then we'll be done for today on the notes. So this first example is the first one so far that doesn't work right from the bat because if you remember, the two smaller sides need to be bigger than the largest side, and in this case 7 plus 9 is 16, which is not bigger than 18. So for this one, all we can say is that it is not a triangle. So that was actually something that we learned earlier on last unit, I believe. So that's something that still is in play. So you have to remember that first you have to actually check, well, is this a triangle? And in that case, it was not. All right, let's see. Number 5, we have 16 squared, 20 squared, and 30 squared. So 16 squared plus 20 squared gives me 656. 30 squared gives me 900. So 656 is less than 900. And so if I went back up to see which one that lines up with, that means that this is an obtuse triangle. And if I were to check if it were actually a triangle, it does work because 16 plus 20 is 36, which is bigger than 30. So that does work. And now we'll just have one more example for today. And again, if you check, if you add these up, it's bigger than 82. So it is a triangle. We just have to figure out what kind of triangle it is. So 18 squared plus 80 squared gives me 6,724. 82 squared, 6,724. So this is another right triangle. So you can use these theorems to decide what type of triangle it is.